In the last tutorial, I explained how the every function works in JavaScript. In this tutorial, I'm going to explain the sum function. Now, the sum function is very similar to the every function in the sense that we're going to be iterating over every item in an array and passing it a test function and analyzing the result of that test function to see whether it produces the value for true or the value for false. For every, in order for the result of the entire operation to return true, every value in the array had to be true. In this case, what we're analyzing is our value, which we're calling color, equal to the string value of blue? If it is, return true, otherwise return false. So for the first array, what this is going to do is step through every index here and analyze the value and see whether it's equal to blue. And in this case, it is. So in our earlier example for every, the result was true. Here's my tab from the earlier video, which I've only made a few changes. One of them was renaming this function allBlue to SumBlue. In this case, this will still analyze to true when we use sum, but for different reasons. Because this time, at least one is true instead of all of them being true. So if you remember from the earlier video, when we were analyzing every, it would start at the first index and say, is this equal to blue? If it was true, then we'd say, okay, great, let's continue and check the rest. Is the second value equal to blue? If it is, good. Is the third one equal to blue? If it is good, then we can return true the entire operation. This time, what we're going to do is say, is the first value equal to blue? Because we're using sum now. Yes. Okay, now we can just terminate our operation at that point, which is what the JavaScript engine will do internally when it runs this function. It only needs to run this test function once because the very first time it got back true. Therefore, it knows that some of the values are true, or in other words, at least one or more. But what will it do for mixed colors? Well, for the sum function, we'll look here and it'll say, is red equal to blue? No. Okay, well, let's keep analyzing because we have more values to analyze. So we'll look at the second one. Is blue equal to blue? Yes. Great. That means at least one or more is equal to true. Therefore, we can terminate at that point and save CPU cycles. We don't even need to look at green. And this will return for result true. For result 2, the value of true. So let's copy this into our console just so we can prove that this is the case. Let's take result 1, copy it in. That's true. Result 2. That's also true. Whereas before, when we were running every, it was false. That's the basic idea. That should be enough to get you going. However, in our previous video, I went into a more complicated example for analyzing a Fibonacci sequence. And I used the every function to determine whether a set of values in an array was a Fibonacci sequence or not. And now I'm going to use a similar example, but use sum, and we're going to see what happens this time. So go ahead and copy in these arrays. And let's copy in the function because I changed the function name. And then let's run the first example, and then I'll walk you through it. So what was the result 3? It was true. Now, what are we actually examining this time? Because we're calling some instead of every. So what impact does that have on our algorithm? Well, let's walk through it. So remember, we're going to start at the very first index 0 here. And it's going to come into the function and it's going to say, okay, we're at index 0. Is the value equal to 1? Yes, it is. So that's true. Therefore, at least one of the values in our array run against our function equal true. Therefore, we have a result of true for some. One or more of the results was true. But that doesn't quite make sense, right? Because in order to have a Fibonacci sequence, there are two different things we need to look at. One is that the value of the first two indices are equal to 1. And the second rule is for every value after 1, or after the first two, I should say, does the value equal the summation of the two values before it? So a more accurate way to analyze this would require a much more complicated function. But for the sake of demonstration, I'm going to remove the first requirement and we're just going to analyze the second requirement. So let's forget about this rule for now. And let's analyze just whether we have a subset of Fibonacci sequence within our set of values, disregarding the first two values in a typical Fibonacci sequence. And in order to get that result, let's modify our function a little bit. And let's say for the first, or for the index 0 and the index 1, if that's our index, let's just return false and not really consider those. And now let's copy this function. And again, actually, first let's clear our console. You can do that with the keys Command K. Then copy in our function with the modification here. And you can tap the up key on your keyboard when you have a blank blinking cursor in order to select lines that you had previously executed. So tap up twice, 3 times actually. And we'll actually need to get rid of the let there. And because we're just going to overwrite result 3 with our new result, hit enter. And we get true. Now, how did that happen? Let's walk through it. So it's going to come here to index 0 and return false. It's going to come to index 1 and return false. But when it gets here to index 2, now we have gotten past our if statement, and now we're down here in the bottom part of the function. And does the value of 1 plus the value of 1 equal 2? That's true. Therefore, the result of our sum method is true, the result of our operation. In other words, does one of these values, other than the first two, equal a subset of the Fibonacci sequence? Yes. So that's why we got true for that result. Now let's do it for the second one. That also returned true for the same reason. It didn't worry about that this time because we're ignoring that rule. Didn't worry about that. Turned false for both of those. And then it got the 2. And then what happened there? Well, does the value of 0 plus, or does the value of 0 plus the value of 1 equal 2? No. Okay, so this time when our sum function started to analyze the value at this index, it returned false. So it would actually have continued here to this value. Now, does 1 plus 2 equals 3? Yes, that's true. And therefore, the result of the entire operation is true. And you can see there that we printed out to the console twice. Next in sequence was equal to 1 when we got to the index at value 2, because 1 plus 0 is 1. And that evaluated false, but then it did it one more time. It said 1 plus 3, or 1 plus 2 is equal to 3 here, and therefore we got true for the entire operation. Now let's do this one more time. And we get true there again, because the same thing will essentially happen, is we get to 3, and then 1 plus 2 does equal 3. And so it says, well, at least there's a subset that equals the Fibonacci sequence. Therefore, in this situation, because we're using the sum method, it's true. Now, could we break this so that it did not return true? Yes, we could. So let's do that. Let's see what happens if we remove this 2. Now copy everything but the let keyword for number set 3. And let's clear the console. Copy that in. And then hit up on your keyboard a couple times. So we want to overwrite result 5. Okay, so now it's not true. Now how come? Let's walk through it. So the first 2 indices return false. 3 is not equal to the summation of 1 plus 1. 6 is not equal to the summation of 1 plus 3. 8 is not equal to 3 plus 6. And 13 is not equal to 6 plus 8, because that equals 14. So none of those values equate to true. So none of them are a subset of the Fibonacci sequence.